Wi-Fi Sheep would like to say a huge thank you to all of you that kindly support us. Help us continue to bring new videos like this. Join patreon.com/Wi-Fi Sheep from just $1 a month. Hello and welcome back to Wi-Fi Sheep here on YouTube and part 2 of our TinyBASIC computers project. In today's video we're going to build a real 8-bit programmable computer. This is one of the most simplest ways to build a working computer with a keyboard for input and text video output. If you've not done so already, do go and watch part 1, the project introduction, which will explain exactly what we're trying to achieve. And also do consider joining our free TinyBASIC Computers community Facebook group, where you can access the required Arduino hex files, as well as get help and future program listings. We also have a regularly updated download toolkit, which contains everything you need, including hex files, programmers' reference guides, PC software, and additional documentation. It's available on our general support and downloads $3 Patreon tier. Visit patreon.com/Wi-Fi Sheep to join today. Before we continue, I want to tell you about the turnkey PCB assembly services provided by our partners at PCBGOGO.com. These include PCB manufacturing and assembly, component sourcing, functional testing, and IC programming. PCBGOGO's manufacturing bases are equipped with the most advanced production equipment such as Yamaha pick and place machines, reflow oven, wave soldering machines, and AOI testing machines, all operated by highly skilled technical personnel. Although PCBGOGO's international operation is only 5 years old, their factories and world-class production facilities have over 10 years experience in the PCB industry, serving Chinese domestic and internal markets. PCBGOGO provide easy and cost-effective online ordering services from prototype to mass production. So join now. Sign up for your free account today at PCBGOGO.com. Now, our TinyBASIC Computers project is designed for the total beginner and to be as low cost and as easy to build as possible. That said, today's tutorial is going to make this a slightly longer video than normal. I also must stress that the processes shown here are emulated strictly at your own personal risk. However, if you're ready to follow along, then let's get building. Now, in order to make this project work, we're going to power it around the Arduino Nano. And it happens I have one here, which I've already pre-opened. So let's just have a quick look inside, see what you get. So here is a clone Arduino Nano, so it's not an official one. And this is one that comes pre-soldered with the headers either side. And it's got a bit of foam on the back, which we can take off. There we go. So the main processor on top is a Atmega 328 8-bit microprocessor. It also contains 2K of RAM on board. Underneath there is a EEPROM, which is a 1K EEPROM for electronic storage, which we will be using. It also has the clock on board, and it's clocked to 16 MHz, which is quite fast for an 8-bit machine. You may notice has a mini USB on the end, and we can use that to interface with a computer. Now, for interfacing, I'm going to use USB cable. I've got a standard USB on one end, mini USB on the other, so we'll plug that straight in. And then to power up off the mains, I'm going to use a Apple iPhone charger. So this has got the UK standard plug for 240 volts one end. We've got USB 5 volts out the other end. Okay, so let's just plug in and power up straight off the mains. Now, this one, like most of them, will start flashing. A lot of these cloned Arduinos have a program called Blink, which is a demo program preloaded, which just flashes an LED here on the matrix display. And that means basically it's got a bootloader on board and it's working. So we know that's working, so that's great. So what we'll do now is we'll disconnect and we will plug into the laptop. So we can start installing the hex files onto this Arduino, and we'll have a second Arduino unit here. Now for the actual loading of the hex files onto the Arduinos, I'm going to use this slightly older Windows 7 laptop. It is better to have a sort of secondary or older PC computer to use, something that needs to be a minimum of Windows 7, 8 or 10. And obviously you do all this at your own risk. Okay, so here on the Windows 7 desktop, I've gone and downloaded the TinyBASIC toolkit. This is version 0.11. You can get this from our Patreon. That's patreon.com/Wi-Fi sheep, and it's under our $3 tier. And I'm just going to right click and we'll expand all onto the desktop. So just extract. So what we want is TinyBASIC toolkit, which is here. And we'll double click that, and here is the listings. So what we've got is the hex files, and we've also got the software drivers. Now, if you're using clone Arduinos, you're going to need to install the CH340 Windows driver. This is the driver that will allow these clone Arduinos to actually mount and be loadable on a PC. If you're using official Arduinos, you don't actually need this driver. So we're just going to go CH. Sometimes it refers to it as the CH341 driver, but we'll go setup. Now it's set up 32-bit or set up 64, depending on what your system is. And then you can install a driver as required. The second piece of software you're going to need is called Xloader. Okay, so now we're going to plug in our Arduino. So the USB mini, in our case, plugs into the actual board itself, and then the main USB plug goes into the laptop. Then what we have to do is choose our hex files. So this has already gone to the toolkit. I'll just show you where the hex files actually are. So if we go from desktop under the toolkit, hex files. This version has 3 hex files. The later version will probably have 4 hex files in. So basically you've got TinyBASIC, which is the main basic interpreter we want to install, and then you also have the PAL and NTSC video streams, and that will go on the second of the Arduino boards. But for this one, we'll install the TinyBASIC Plus file. So we'll just select that, open. Now we want to adjust the baud rate, so we need to go a little bit faster than this. So the default it sets to is 57600, and we want to change this number to 115200. Also make sure that you've got the nano selected, and it's nano at mega 328, and this will take just a few moments. Now it might read as upload failed, and I've had this happen a few times, but I reckon it probably hasn't failed. Also on the toolkit, we'll just minimize Xloader in a minute. Let's go back. There's an installer for the current Arduino IDE interface. I have that already installed. Now you don't actually need to use this, but we'll boot it up anyway. Just make sure under Tools that it's got the correct Arduino Nano selected, and you're on the correct port with the correct processor. And then if we look at serial monitor, making sure the baud rating is set to 300, you'll notice that the basic interpreter actually loads in. So it did work even though Xloader said it had failed. And I've had this as a common error quite often. So if I ask for memory, so I type MEM, click send. There we go. It actually, so it's a fully working basic interpreter, so we know that works. So we'll just close out of this. By the way, you can't run the Arduino environment and Xloader at the same time, so make sure you do close Arduino if you are going to use it, and then open up Xloader again. So we'll just repeat the process for the other Arduino, this time loading one of the TV terminals. Now with the TV terminals, let's go back to where those are under hex files. There's 2 versions. There's NTSC, so if you're in Canada, North America or Japan, that's the one you want to use. PAL is pretty much the rest of the world. Now I'll put a link in the description of this video to a Wikipedia map which shows a world map on all the different television standards. We're only supporting 2, those being the main 2. So if you're not an NTSC country, regardless if you're not actually a PAL country, use the PAL as a default. So it's up to you which one you want to use. We'll be using the PAL for the duration of this video series. Okay, so that's both Arduinos now flashed with the Hex files. So this one will be acting as the TV terminal, and this one is the main TinyBASIC interpreter. And what I've done is I've just put a little bit of tape just on top of the USB so I can identify which board is which. So these two are now uploaded and ready to go. Now let's turn our attention to the actual main building of the computer itself. So of all these projects, we're going to start with a solderless breadboard, which is one of these. And again, you can pick all these components up very, very cheaply. The way we're going to orientate this is with the blue line, or the minus rail as we're going to call it, facing at the top. So it is possible to have these the other way around, and that may confuse things. So make sure it's that way around, minus is at the top. Now, for those of you that don't know how these work, it's very, very simple. The board is split up into 4 separate areas. The top area here is the power rail, and it's denoted as plus and minus, positive and negative. And this point here on the minus rail is connected all the way down to this point here, and vice versa, the plus rail here to here. On this side, these 2 rails are also connected along, but it should be remembered that this rail and this rail and this rail and this rail, so the positive and negatives on both sides, are not connected to each other. So if you power up here, you won't be powered down here. Now, the 2 portions here, separated by this deep plastic ridge in the middle of the board, each of these is connected downwards. So this pin here is connected to this pin here, and that one there is connected to there, and vice versa. This one here is connected to here, but here and here are not automatically connected together. So it's across the entire board at the top, and then it's down here and here, but not through the middle. And that's basically how the wiring of the solderless breadboard works. Now, I did say in the introduction video that we were going to be using jumpers, and here's a simple cable jumper, and you can simply plug from there to there. And I will still be using some jumpers, but to make the circuit a little bit cleaner, and so we don't have all this wires hanging out, I'm actually going to cut some cable to use as jumpers. And I've got 3 colours here. So I've got red, which I'll use for my plus or voltage, black for negative, or what we're going to call ground, and we'll use yellow for the internal serial cables or data lines. And all you have to do is to make a jumper. It's very simple. Pull a piece of wire out. I've then got some snips here, and cut a piece of wire. If you've got some proper wire snips, that's even better. A pair of pliers so I can bend my piece of cable. And then if I grab one end, I can just take the plastic sleeve off, carefully cutting, and that exposes the core. Now this is single core wire. If it's multi-core wire, you've got strands of metal wire inside. Just take the pliers, grab the end and just give it a twist. That's not necessary here because it's only single core copper wire. But that creates the plug end, and I'll just do the same on the other side. There we go. And then I could actually use that and plug in to the board instead, and it just has a much lower profile on the board. So that's what I'm going to be using. You don't have to use this method. If you're quite happy with the jumpers, then just use the jumpers and just go from the point to point that I show on the board itself. Okay, so the first thing we're going to do is we're actually going to bridge our minus rail. Now, when I say positive and negative, it's the same as you look on a battery. This is a 9-volt battery, by the way. So we've got negative, positive, and it's exactly the same here. By the way, don't use a 9-volt battery because this whole circuit can run on a maximum of 5 volts. So a 9-volt battery would actually damage things, so don't run off a 9-volt. I'm just showing it as an example. Now, from now on, we're going to call the plus, we'll call that plus 5 volts. And we're going to call the negative, we're going to call that ground, or common ground. And what I mean by that is that most, if not all, of the negatives from all the different parts of this computer board all need to go back and be wired onto one single line and back to the main power transformer. Here's my power transformer again. So this is a standard Apple iPad charger, USB, so 5 volts out, and the British standard, which is 240 volts in. US it's 110 volts in, but it's 5 volts out, so it's perfectly safe to do this. So basically all the ground's going to go back to the mains from the circuit. So the first thing I'm going to do is I'm going to link this to this, and I have here a jumper wire. I'm using black to denote ground cables so I know which is which, and we're just going to plug that in like so. Okay, next let's get our two Arduinos, and we've got the first one which I put the sticker on, which is the main CPU Arduino, and that's going to go here. I'm not going to push them straight in, we're just going to place them for the minute. And the second Arduino, this one here, is going to go roughly here. And when we're happy with the positioning, we need to make sure we do push these down carefully without touching the top of the board. Now, I have found that sometimes the Arduinos don't clip into the board properly, and then you have connection problems. So just very carefully try to hold the sides of the board if you can. And we're just going to work that in until it locks in place. And the same with this one. Make sure that this one is both right up against the end here, and that both sides of the pins bridge over the gap. So you want pins connected on one side, pins connected on the other, but they need to be separated from this central piece here. If you put this in the wrong place, so example, if I was to bridge across here, and that would then short both sides out. So we want to make sure we've got that divide in place. And of course, this one is our, or will be our video. So main computer and basic interpreter here, video will be here. Okay, the next thing we need to do is attach the Arduinos to the power rail at the top. The nice thing about the Arduinos is, of course, they are all labelled. So the pins here are labelled, and we want to, first of all, we need to ground this Arduino. So there's, on the top here, there's a pin called GND, which will be upside down, but it's this pin here, and that's ground. And connect ground like so. Now, the same we need to do with the voltage. But we're not going to go in via the pin labelled 5 volts. We're actually going to go in via a pin down here, which is labelled VIN, which is generic for voltage. And I have here, this is red 5 volt cable, and we're going to go from the voltage pin and just plug in to 5 volts. Again, this can be a little bit fiddly, but don't worry, just take your time. Okay, so that's now into voltage. So this board is now technically connected up to the power rail, and we need to repeat the process the other side. With this board, the ground and the voltage pin are actually just the first two here on the top, so it's a little easier to do. So let's just put the voltage in first, which is the red, and then the ground will go right next to it. Okay, so that's now both Arduinos attached to each other via voltage, and they would actually both power up if we put a current into the board. Right, so next we're going to add a common reset button. Now you don't actually have to do this because both Arduinos have a reset switch on already, but one common button in the middle, which would be quite nice to place, and that'll just make resetting a bit easier. So I have here, this is a 4-pin switch. You can't place the switch like that, or like that, or like that, because it will actually short between the pins, so you have to have it over the gap in the middle. So let's put that roughly, it'll go, let's try to put that roughly there. There we go. And wiring the switch up is very easy because the Arduinos actually have a reset pin on them, actually more than one reset pin. So here you can actually see the pin is on the top, one on the bottom as well, and it's labelled RST, that's reset. And I'm going to use a piece of yellow wire. This is what we're going to use for internal signals with our main voltages. And I'm going to bridge from reset which is there, to this side of the switch. Don't put it that side because the switch is going to bridge across here and make a circuit that way. So we don't want to pull this permanently low. When I say low, a pin for reset works on high or low. So high voltage is if you put 5 volts through it, and low voltage is if we tie it down to ground, which is what we're going to do. So we're also going to attach the reset pin on the other Arduino board to tie them both together, and that will go up here. So we'll go from reset from there, and we'll tie that up there. Okay, so both of these would actually link to each other, but we need to tie it to a ground to actually make a connection, and we can do that very simply with another black lead, and we're going to go here, making sure we actually tie it on the correct side of the pins. There we go. So when we press that button, it pulls both resets to ground and will reset both Arduinos at the same time, helping us to make this a combined system. Okay, next let's take a look at resistors. Now, when you buy resistors, you have to buy them in a number of quantities. You can't just buy one resistor on its own, well, not normally. So resistors normally come packaged like this, and we need at least 4 on our system. Mostly we're going to use these, which are 1K 1000 ohm resistors, and you can read them as a 1000 ohm because they actually have a color code on them. So the color code for the 1K resistor, just keep that in shot for you, is brown, black and red. So the first stripe on it will be brown, the middle one will be a sort of a grey, or what we call a black, and then the third band will be red. There's then usually silver or gold band. Don't worry about that, just read the first 3 on these type of resistor. And we're also going to need a 470 ohm resistor, which has a different color band. It looks almost identical, but it has a different color band. The colors on this are going to be yellow, purple or violet or brown. That's yellow, purple and brown. And these two combined together are going to drive our video signal. So what we want to do is we want to put them roughly in the middle of the board on this side, and we want to bridge between the 2 sides of the divide. Probably going to go just over the top of our reset cable, and we're going to hook one like that. So that's the 1K going there, and then this side here we're going to use the 470 ohm. Now they both need to be separate here, but they need to join each other here on the same row. We're making a circuit. Let's just make sure we get those together. There we go. So when generating an analog video, you need the video data, and you also need what's called a sync pulse, and that's why we have 2 resistors going into one, which will go out to our video cable. So the 1K, which is this one here, is the sync pulse, and the 470 ohm resistor actually going to carry the video data. And we need to take these from pins from our video Arduino here, and the pins we're going to use are the D pins, and they're D9 and D7. So pin D9 wants to go to the 1K resistor, and again we're going to use a piece of yellow lead or yellow cut cable, and we're going to bridge from pin D9 so we're going from pin D9 to the line with the 1K resistor on, which then joins with the 470, and we're going to have a slightly smaller piece of cable to link the 470, which is carrying our video signal, and that's going to D7, so pin D7, which is here. There we go. Now, in order to connect on the video lead, what we're going to do, remember we're not using soldering, I'm not allowed to solder for this, is I am actually going to use a proper jumper lead, And I'm going to put one end just into the top of the row that the two resistors meet on. So this and this resistor are connected together, and they're then connected to this lead, and we're just going to leave the end of this hanging off the board for the moment. So that's actually the video signal done. While we're here, let's do the sound signal. And the sound signal uses another 1K resistor. By the way, it doesn't actually matter which way around you put these resistors, so they're not what we call polarized, which means the positive and negative can be either side. It doesn't actually matter. So let's put the sound resistor for our sound circuit roughly about there. Again, just bridging the gap between this side and this side of the main board. And now we're going to link this side of the resistor to pin D5 on the main computer control board. So I've got this pre-made up piece of wire, and we're going to link from down here, and we're going to go into pin D5, and then we can add, in this case we'll add a red jumper lead, and again we're just going to go from the top of where the resistor is plugged in, and we're going to leave that one hanging off the board as well. So we've got sound will be on this pin, and we've got video on this pin, and we'll just leave those two there for the minute. So we're actually very, very nearly finished the build. One extra thing we can add, and I do recommend it, is a ceramic disc capacitor. This is a 104 ceramic disc capacitor, and basically it just acts as a voltage smoother. So if you have what we call a dirty power supply, so that's voltage coming in that's waving up and down, it's not quite exactly 5 volts, just under. This acts as a little battery, and it charges up, and if there's a drop in voltage it will then discharge and make up the difference. It just helps to smooth the voltage out and helps with things like interference and any rogue blips in the power supply. So we just need to bridge that across what we're going to use as our main volts rail. So we've got positive and negative up here. We're just going to put one end into positive, one end into negative. Again, this doesn't matter which way around this particular type of capacitor goes. So just put that in there, and that will help just to smooth out the voltage and make the whole thing hopefully run a little bit better. While working on top of the board, we need to add a ground return, which we can use as a common return for both the sound and the video. So we've got these two here, and we're just going to use a black small jumper lead, and I'm just going to poke one end into the negative ground rail at the top, and again we'll leave those three hanging off ready to be wired up in a minute. Now, one thing to make the system work is we're going to need to drive some computer data. So the data that comes out from this Arduino needs to be transferred as text information to this Arduino to then be displayed as terminal information on the screen. To do that, we're going to use a simple wire to bridge between the two, and we're going to use the TX and RX or serial pins on both Arduinos. Now, because I might need to disconnect the serial for reasons I'll explain later, I'm actually going to use a jumper wire for this. And from the main CPU board, we're going to attach this to the pin labelled TX, which is transmit serial. And we're going to link that all the way down here to the pin labelled RX, which is receive serial. And that creates the physical serial link between the two sides of the system. So they're now connected via the reset, via the voltage, and now via the internal data line as well. While we're here, I'm just going to add an additional power LED. We need another 1K resistor for this. And it also means I can hopefully tie this lead just down underneath so it stops it floating in the air. So first thing to do is we're going to take this resistor, and where it says 5 volts on this pin here, we're going to connect it 5 volts there. And we're just going to come out over here, and we're going to connect still just in a long line just here, so not into the ground rail. And then the LED, now LEDs are polarized, and the legs on this are a bit bent unfortunately, but actually one leg you'll find is longer than the other. So the long leg is the positive and the short leg is the negative, and we want to ground this. So the short leg is going to go into the blue rail on this side, and the long leg is going to connect into the same line as the resistor. And what we can actually do is we can just take our lead and just pin that underneath and use the LED just to hold it down and that should create our power LED. You don't actually need a power LED. There are little LEDs that light up on these boards you've already seen in the video. It's just nice having extra LEDs. So we've got the reset button and power LED. Okay, can you believe it? We're nearly there. We've just got to now wire up our keyboard interface, and then we've got to do something with these lines for the video plugs, which we'll do in a minute. So first of all, let's do the keyboard interface. That's going to be quite important. And for this, we're going to use this off-the-shelf. This is a PS2 type PC keyboard connector, and it has pre-soldered 4 header pins on the back. PS2 was an older IBM PC standard used before USB was adopted. This needs to use PS2, it can't use directly USB. However, what you can do is, if you've only got USB PC keyboards, most of them still have what we call a PS2 protocol on board, which means you can get these adapters very cheaply, and it's PS2 on one end, USB on the other, and you can plug that into that. And then you can actually plug a PC USB keyboard in, and it will actually read correctly as PS2. And then we can then link these 4 pins to the pins on our main master Arduino. To do that, I've got 4 more jumpers in 4 different colours. These are male, so I've got a pin on one end, and then they've got a socket female plug on the other end. And what we want to do is to separate it into 2. So we've got red is plus volts, 5 volts. Black is obviously negative or ground. And you see this is actually labelled. You can see that. So it's actually quite easy to make sure that we plug this the right way around. So it's 5 volts positive goes there, negative on there. And then we've got 2 data lines. And these are clock and data. Clock in this case will be green and data will be blue. I'll just plug those in like that. So let's put our connector just down to the side. Now let's look to plug in the cables into the board. So plus red can go on the plus power rail up here, and next to it neutral or ground can go there. And it just leaves these 2 pins to plug into the Arduino. So as I've already mentioned, the data, which is blue, needs to go onto pin 8 or D8. Let's find D8. And green, which is our clock, will go on D3. And that's our actual keyboard wired in, ready to go. Okay, so finally, let's have a look at how we're going to do our video and sound. So we've already done the circuitry for it, and we've got these pins here. So let's just take the board down here so we can see up here what we're doing. Now I've got one of these, and this is a 2-way RCA cables. These are called RCAs or phono leads. And one is going to be needed for sound, the other is going to be for video. And you can see on the back they've got 2 pins each. Because we can't solder, that's a rule, we're going to use alligator or crocodile clips, and I've got some here. Now I'm going to colour code these. I've got 4 in all, and we're going to use the white ones that are going to be our ground, so white will go to black. So the ground on these is always at the top, and so we can plug one white into there, and the other white leads, let's plug that the other way around, into there. We've now got the 2 cables here, and let's clip both of these onto the single black ground pin, making sure you get a good connection. There we go, so that's now on. I'll use yellow for the video, and if you remember, confusingly we use the white cable for the video, so we're just going to clip onto the end of the white lead here, and I'll plug this one. I'll use the black here for video. So we just plug that onto the middle, making sure that you don't touch the white crocodile clip leads. These 2, make sure these are not touching. They have to be separate, otherwise you'll create a short. And then we can do the same with the red for the sound. So this is red to red. So here's the red plug. We're just going to clip that on the end. And then I'm going to clip that underneath. Again, making sure it does none of these touch. That's fine. So those 2 are now wired and live. and we can use an RCA style video lead if you have a TV or monitor that will support them. So I've got some plugs here, and we'll plug yellow into black for video, and I'll plug red into red, and that'll be the mono sound. So we've got video and sound, and the other end of this cable will plug into a compatible TV or monitor. We're nearly ready to go. Just need to plug a compatible USB keyboard. I have one just here. So we'll plug our USB in. This will be our keyboard. Remember, you've got to have a keyboard with PS2 protocols to work. And then for actual mains power, to make this work, I've got a USB, standard USB to mini USB, which is what these Arduinos need. So I'm going to plug the mini USB, the same as when we did when we wrote the code from the computer. I'm just going to plug into there, and then take my iPhone charger, plug the other end in. We'll plug that into the mains, and we can actually do a really quick test just to make sure this works. Let's just check all the voltages are in the right place before we go any further. It's looking all right, so let's just power up and see what happens. Okay, LED on. I hit reset. See how it both resets? That's great, so that's working. Okay, for a video out, one thing I do like to use are these little black and white analog CRT sets. I find these all over the place in junk shops and thrift stores, and I don't know what it is, but if I see one, I kind of like to pick it up, especially if I show like this one. It actually has composite video and mono sound on the back, which is what we need. So the picture quality of these things is absolutely abysmal. You can plug them into modern tellies. I mean, I've got a flat screen just here and it works fine with that, but there's just something about this that looks kind of cool. It gives it that kind of homebrew computer retro vibe, so I really do like running on these, but as I said, the picture quality is usually quite naff. So let's just plug that in, yellow to yellow, and just to confuse matters, it's actually red to white, but that's just the sound. So we'll pop those in. Now let's put power and see if we boot the computer. And there we go. Okay, so I've literally turned all the lights off here in the workshop and closed the curtains so you can hopefully see a little bit better on screen. It's never ideal to shoot straight onto CRTs and cameras, but this will work. So let's just retest to make sure we are actually working correctly. So I'm going to hit the reset button in the middle of the board. There we go, and that's actually reset quite nicely. Let's test if we've got memory in the system. So just type mem, enter, and there is the memory reading. And we can also test the sound. So let's go tone, let's say 500, so that's the level of the tone, and then the duration, let's say 1000. Okay, that was a bit loud. Let's turn that down. Let's try that again. Oops, if you make a mistake, by the way, there's no return. You can't backspace, sorry. You just have to press down to try again. Tone, what did I say? Let's say 400, 700. By the way, you may notice you get a little bit of distortion. That's because the signal from the computer to the interpreter for the terminal sometimes picks up interference, even in this circuit. Don't worry about that, it will actually still work. That's actually too low now. But I think we can ascertain that tone is working. So we type buy, that'll reload. New, we'll start as a new basic session. List, would list anything if we put anything in the program. And then we can do a hard reset using our button. And there we go, we're actually up and running. Not perfect, we've got a bit of distortion here. That should read hello, and it's missed out the first two characters on boot. But overall, that's actually not bad. So hopefully you were able to follow that and now have or will be successful in getting your own TinyBASIC computer up and running. If you want to share your build and join our new online community, then look no further than TinyBASIC Computers Facebook group at facebook.com/groups/WFS TinyBASIC. So now you've built your first ever computer, you might want to know how to program it. Well, next time we'll look at programming in TinyBASIC, writing some simple programs, as well as going over the system commands and operations. It's really very simple and perfect if you've never coded before. And that's about it for this video. Thanks for sticking with it. Don't forget our Patreon if you want to help and support the channel. It's patreon.com/Wi-Fi Sheep. You can also join us on Twitter. It's @Wi-Fi Sheep. That's @Wi-Fi Sheep on Twitter. And if you've not done so already, don't forget to like and subscribe. Click the notification bell to make sure you don't miss any future Wi-Fi Sheep content. So until next time, best of luck with your builds, and as always, thank you so much for watching, and bye for now.